So I will be with you guys for next 5 days. So let me just share my screen. I hope you can share my screen. Please let me know. This is just
Yes,
a
sir.
confirmation. Great. Now, I am Sachin Chauhan and I'm working as Microsoft certified trainer. From past 15 years, I'm working with a company called Koenig Solutions. And in total, I have an experience of more than 19 years in IT industry. I started my career here in 2006 as .NET trainer. Then I upgraded myself to all the new technologies of .NET. Then I entered into SharePoint development, and now I'm into Azure. So I'm taking care of Azure development part like AZ204, AZ220, AI100, and now trying to get into Power Apps also. So in the span of like 15 years with this company, I got a chance to impart training from within India as well as in other part of the world. Approximately 20 countries I have visited to provide the training, and I'm feeling lucky to provide you the training for AZ20 on behalf of Microsoft. So I hope you will going to enjoy that. Now the training for AZ220 is actually for 32 hours. Right, but we have to complete it in 5 days. Sorry, 15 hours. So it will be a very fast track course. So the main motive is to make you familiar with what are the basically features of IoT, what are the components involved in it, and where they fit in the environment. So that whenever the requirement will come, at least you know that how to solve that. You need to dig into. Right. So you have to put a lot of efforts after completing the course. Most of you might have worked with it, but most of you are new to it. So it is something which you have to work on a lot. Right. So I can only guide you what is in the product and how to work with it. So the labs which are designed with it basically are in .NET. So .NET C#. So I'm expecting that you are good in programming, specifically in .NET if you want to do the labs. If you are not a .NET developer, then it will take a little bit more time to do the labs. Though you can implement the functionalities in other languages like Java, Python, right, PHP, but the labs are designed in .NET. I will be telling you how to work with the labs later. Let me start with the very first topic for today, that what we have to do. But before that, let's see the schedule. So the schedule is like 2 to 5 p.m. for 5 days. And we will take a maximum of 10 minutes break in between. Maximum, I'm saying that because 3 hours is nothing. And today we will complete the first 2 modules. In total, we have 11 modules. So from Monday to Thursday, we will complete 2 modules a day. And on the last day, we will try to complete maximum 3 modules. Then we will be completing our task. Now let's see what is this? This is the official course provided by Microsoft. So I am going to follow the PowerPoint presentations. Now, the thing is that this is a very fast track. So I will not dig into the simple things. I will try to make you familiar with the concepts, right? What they have explained in the PowerPoint presentations. So I might skip one of the slides, right? Means few of the slides. Skip means I will just open it, explain the words on it, explain the sentences on it, and I jump back to the next one, right? Because those things might be very basic for you or which we have already covered in the demonstration. So let's talk about the course content. So I have already explained or I have given my introduction. So I know about you guys, that where are you from and what company you are in. The timings we have already discussed. Course agenda, so we have 11 modules. So first module is all about introduction to IoT and Azure IoT services. This is a general overview of IoT. What is IoT, why we need it, or what are the benefits of it, what is the architecture of it. So this is a very basic module. Second module is going to talk about one of the capability of the IoT, that is called IoT Hub. So how to work with IoT Hub, what is the role and responsibility of IoT Hub, and how it works with it. Then third module is all about DPS, that is called Device Provisioning Service. What is the role and responsibility of device provisioning service and how to create it, how it is integrated with IoT Hub, and how it fit into the IoT solution. Fourth module is all about message processing and analytics. When your devices can send the messages, so when it receives by the IoT Hub, so what you can do with that messages, how you can forward those messages, where you can forward those messages, and how you can analyze those messages. So module 4 and 5th is related to the messaging. How we can analyze the messages is a little bit more in depth. We will going to cover in the 5th module. Right, it is just talking about the services like time series insight service and how we can integrate it with Power BI. Sixth module is all about IoT edge deployment process. So here we will talk about what is IoT edge device, how to configure the IoT edge device and IoT edge gateway devices, how to install the custom modules in that. That is module 7. We're going to talk about how the modules and containers are related to it. Eighth module is all about device management, how to manage the devices, how they can communicate with IoT edge device. Then comes module 9, which is basic in every software development life cycle. We follow that, how to test my application, diagnose it, and log the information so that whenever we need, we can analyze it, we can take decisions on it. Module 10 is all about your security features. So when we talk about security, so in the security features, we talk about there is a predefined guidelines that we're going to talk about here. So how the Azure will going to take the benefit of security center for IoT, and if we want to implement the security features for my IoT environment, so how to do that, how to grab the security details from the resources that are running using IoT agent. And last but not the least is all about IoT central service. So till module 10, whatever services we are talking about, they falls into platform as a service, PaaS services, which give us full control on individual services. But if we want to quickly and rapidly create our IoT solutions without digging into each and individual service, so we have a software as a service called IoT Central, which allows me to create an IoT solutions quickly and efficiently based on the templates. So we're going to talk about all these things in 15 hours duration. To work with this, you should have a good understanding of Azure. So if you are familiar with the AZ900 course, then this course will make a little bit more sense to you guys, along with the programming skills, right? So here we're going to talk about all the features that we have discussed, like IoT Hub, device provisioning service, and Azure Stream Analytics, Azure PaaS services, time series insight, IoT Central, and so on. And there is a labs associated with it, which I will be telling you how to do that after completing the first module. So prerequisite, as we have discussed, that you should have a software development experience. You should know how the data can be processed. And last but not the least, the Azure fundamental training you should have gone through that also. The exam point of view, I'll talk about exam things on the last day, right? What you have to focus on. So they have just defined that if you want to clear that exam out of the whole curriculum, they have defined different categories and how much percentage of exam will come into from those categories, right? The exam will be of 1000 marks and you have to score 70% to clear that exam. And it is all objective types questions. So drag and drop questions are there, objective types are there, obviously, and multiple choice are there. There is no negative marking. So you will get 2 case studies also, from 2 or 3 case studies from where you have to select the appropriate answers. Hand-ons, I told you that there is a lab associated with it. I'll tell you how to do that afterwards. Okay, so that was just an orientation about what we have to complete. So today my motive is to complete the first 2 modules. So for that, I will open the very first module. And that module is going to talk about introduction to IoT and Azure IoT services. So before jumping into, I'll go to my Word document. So in the Word document, I have just already added the module 1 and the topics that part of it, where it will talk about describe the core components of Azure IoT solution architecture. Describe the IoT services and how they contribute to an IoT solution, and just how to work with an Azure account and how to work with a portal to create IoT hub and device provisioning service. Now, device provisioning service is a third module, right? So we're not going to talk much on that at present. So I'll ask one question from you. You can put that into the chat window, right? What is IoT? What do you think an IoT is? So you can just let me know. If you want, you can unmute yourself, one of you, miss, and then you can let me know. Otherwise, I can see in the chat window. Yes, please. What do you think an IoT is all about? And quick, participation is appreciated because we have a very less time. So Internet of Things, okay. Internet of Machines to communicate with one another. Nice. So yes, it is, but when they are connected to each other, what they're doing it. Bridge between devices and softwares and human world. Okay, good. So I will put that thing into words like the IoT is a network of, so IoT is a network of internet connected devices that communicates embedded data, embedded data from the sensors to the cloud for centralized processing. Centralized processing. So if you take an example of the IoT bulbs, right? Now we have smart bulbs available, which we can install it at our home. Now, no matter where we are, we can install the app on our mobile, and from where we can control that bulb. Right, we can switch it on, we can switch it off, we can change the colors of it, right? Everything we can do that. But how we can do that actually? So those devices basically are getting its information from the mobile devices using the internet, right? So in the internet, we connect to the internet, we give the instructions, it is processed there, and then the result will be available to the devices. We have the auto-driven cars are there. In auto-driven cars also we have sensors. Those sensors will collect the data, like whether you are in a particular lane or not, what is the distance of the next car from you, and all this information is sent to the cloud, where my application will collect the data, process it, and then give the response back, whether you need to apply a brake, whether you have to slow down, whether you can overtake or not. All these things can be achieved accordingly. So that's what IoT is. Now, IoT says that sensors data. Now, it means that every device which wants to be a IoT device must have the sensors and controllers installed on that. So sensors are the devices which can, where I will write my application to collect the different piece of information of my interest, like temperature, humidity, GPS data, and so on. And then my controller will collect the data and then pass it to the cloud, where it is being processed, and I might get some response back if I need it. So the core components, the core components which basically we will work with, right, are basically we'll talk about. So the core components that makes your IoT solution. First is the device side. That act as a data source. And second is the cloud side. A cloud side, right? Cloud side that gathers the data and process it. That gathers the data and provides the resources for analyzing. Now, if I draw it, so if I put that it into the figure, I can say that this is the device side and this is my cloud side. So this is the cloud side. So on the device side, I have basically the applications which are running on the devices. So it is called IoT devices where sensors are installed. Sensors and controllers are installed. Controllers are installed. And my application is sending that information, sending data from sensors to cloud, right? To cloud. And in the cloud, I have the services which are collecting the data. So there is a service that I'm going to talk about that is called IoT Hub. So IoT Hub is a service which acts as a gateway service, right? Right, which collects the data. It act as a gateway service, right? Gateway service which has so many responsibilities. The main responsibility is device management. Device management means it will contain the information about which devices can connect to it and send the data to it, as well as it act as a message broker. Message broker means it collects the data, keep it with it and forward it to the destination for further processing. So it works with it. So the data it collects from the devices are stored maximum for 7 days, right? And it also has the ability to get the data from backend application, which is stored for maximum 48 hours, means 2 days. So it means that this is the backend application that I'm going to talk about. So which is running in the cloud. So this is a backend application. Which can process the data. So now you have sent your data from your devices to the cloud, and then it will forward that messages to the backend application. It will process the data and it wants to send some result back to the devices. So it sends the data back and then it will be forwarded to the devices. Now let's assume that if a device has sent the data to IoT Hub and your backend application or services not available. Can you mute yourself, please? If you don't have any question. Thank you. So if your service backend application or the services are not available, it will keep the data for 7 days. And within 7 days, if the applications are available, they can collect it. Exactly in the same way, when backend application want to send the data to the devices, if device is, let's say, shut down, it is not available. So that data is kept with the IoT Hub for 48 hours maximum, and then it will be forwarded to the devices when it is available. The configuration, you can configure it from 1 to 7 days, and hours is from 1 to 48 hours, that you can configure it accordingly. Now, whatever information we have discussed now, based on that, we will talk about the core subsystems. So core subsystem of IoT solutions. So based on that, the first is your devices that have the ability to communicate with cloud securely, right? Cloud securely. Then second, a cloud gateway. A cloud gateway, which is called hub, let's say hub or IoT hub, to securely accept the data from the device. And it provides device management capability. Capability. Then next component is your stream processor. Right, stream processor that will consume the data. That will consume the data, right, and perform some business processes. Process and then store the data depending on the requirement. Depending on the requirement. Last is a user interface to analyze the data or for visualization. For visualization. So these are the basic core subsystems that you will work with. Now, how these things are categorized. So if you want to create IoT solutions, your whole architecture is divided into three main categories. So the first category is things. So they call it things. Things. Second is your insight. It is not application insight. They're just giving it a name insight because you're analyzing the data here. So insight. And the last one is called action. Action. So the flow is from things to insight, insight to actions. Now, what are the components that are part of it? So if we talk about things, it is all about client side. Client side. So on the client side, I have devices. So I have devices, and those devices are IP enabled, IP enabled, or non-IP enabled. Non-IP enabled. So IP enabled devices means which can publicly connect, which can connect to the public internet, right, directly, and then they can send the data. Non-IP enabled devices are the one which do not have the internet capability, but still can communicate with other devices using a short-term protocol like Bluetooth, right? Okay. Now in the Insight, we have the IoT hub as we discussed. We have IoT hub. So we have IoT hub. And other services are there which IoT hub can use, means because IoT hub, as I told you, it has the device management capability. It has device management capability. Right, device management capability. Along with that, it will have the information about it, act as a message broker. So message broker. So whenever the message is received by this IoT hub using the devices, it can basically authenticate a device where the request is coming from, and it accept the messages and then forward the messages to other services for processing. It can forward the message to the stream analytics service and analytics, right? Stream analytics service. It can forward the data to service bus, right? Service bus or to the storage. And then it might wants to process the data or view the data. So I have the UI. So we have a UI, user interface. So here I can also add a UI capability. So I'm just adding a box here that will fit it into the category of this. So here, the UI, user interface. So for analyzing the data, it comes into the inside section, and whatever is in the service bus, right, can forward the result to backend application or to my code for processing. So business process can be executed here. Even the storage, whatever data I have stored in the storage, can be used by machine learning algorithms and then forward that for further processing for BI. Even UI capabilities are there, which I can use to manage and view the business processes. So this is a general overview of it. Now, there are a lot of other services out there that I can integrate, right? But this is a general overview of that, how the things are being organized. Now, if you want, you can think about that there is a garden, right? There is, let's say there is a city, and in that city, there are a lot of gardens available in each society. And you want to keep track about that how much water supply is required, right? Because it will going to cost you. So how to know that how much water supply is required? So what you do is you want to get the information about humidity and the temperature in that garden. So you install the IoT devices into the garden, and those devices have sensors which will collect the temperature and humidity. That information is passed to the IoT hub. IoT hub will process the data and then take decisions that if this is a humidity, this is a temperature, how much water is required for the same. So this is a simple example of it. Now, whatever devices you are having onto your garden, right, it is not like that every day you will take it out and then charge it and then keep it there. No, the devices that are IoT capable devices must have the ability that you don't have to charge it every day. It, like, once charged, it can be, it should run for at least few months, 3 to 6 months, right? First, capability should be there. Secondly, the operating system that is running onto it must be lightweight, right? As well as the benefit that you will get, that you want to, if you want to update it, if you want to update some firmware, if there is any issue, you don't want that any like a engineer should visit that place and modify that. You want to have the ability to rectify those errors, to update the firmwares remotely. So all these capabilities must be there, that you should have on your devices, right? So that's what they're trying to talk about. Now, this is the basic components into it. Now, there are other services are there which you can work with. So the other services are like, if your devices are IP enabled, right? So they can easily communicate with the IoT hub because it is running in the cloud. They say that, okay, I would like to send the data to the IoT hub. But if the devices are non-IP enabled, in that case, how they will going to communicate with hub? So in that case, we have other devices that are installed on the client side that are act as a IoT gateway. And the non-IP enabled devices or even IP enabled devices can send the data to the IoT gateway, where you can process the data and forward to IoT hub. So in this case, you are managing it. So this is another way by which you are sending the data to the IoT hub. As well as one more thing, that if you are managing the devices, right? So IoT hub says that I'm managing the devices. So if there are 1 or 2 or maybe 4 or 5 devices, I can manually go and say that these are the devices that can communicate with IoT hub. But if there are devices which are in thousands or hundreds, so it is not possible for me to manage the devices manually. In that case, I have another service, right, that is running in the cloud and that sits between your device and the IoT hub, that is called device provisioning service. Device provisioning service act as an intermediator whose responsibility is to manage the devices in the IoT hub. So we have a device provisioning service that act as an intermediator. Now let's take an example. I am an IoT hub and you want to communicate with me. You are the devices. So first of all, what I'll do is I will make some entries with me, like entry 1. I will take the entry of the passport, right, of yours. So there are 50 students, so I will keep 50 passports with me, right? And I say that if anybody wants to communicate with me, you have to bring your passport with your request, so that I can check if the passport is what I am having. If it matches, then only you can send the messages to me. But it is not possible for me to manage these passport entries manually because it can be in thousand, right? So what I'll do is I'll hire a personal assistant, right? PA. And a personal assistant is the one who will manage that. He who says that which devices can be registered with me, right? Which can communicate with me. So he is responsible for deciding which passport should be available to me with the entries, and then you can use to communicate with me. If anything need to be deleted, so he will delete that. So I don't have to manually delete it. Is managing everything that which devices can communicate with me, right? So DPS is doing the same thing. So this is what they talk about. Another capability is that, like, I have created one IoT solution. I have created second IoT solution. So I have many IoT solutions available. Now, every IoT solution has few things in common that they want, like security. Every IoT solution needs a security. Logging and diagnostics. Every IoT solutions wants diagnostic features, right? Every IoT solution needs other information about security, like as I told you, right? So how to do that? Either I can write a complete logic in my application for that, but if I need the same logic in multiple application, so I'm basically redoing the same thing, right? I'm not doing smart work, I'm doing hard work. So there is a concept of, what is that concept called? Cross-cutting edges. Cross-cutting edges is a concept where I'm defining the functionality once and reusing it. So cross-cutting edge is a concept of defining the concept once and reusing it multiple times, reusing it whenever required, right? So I will define uh, the security things, like how I want to have a security. So I'll implement that, the services features, and I can configure it with my service as per my requirement, right? So diagnostics, logging, all these things act as a cross-cutting edges, monitoring, because I want to use it with many applications. So Azure has created that functionality. You just have to attach it with your application or with your IoT solutions, and you have to configure it. So that's what they are trying to explain in this whole module. So let's go with this module and let's see what they're trying to talk about. So if you want, I'll just make one more little diagram to make the things clear. So I'll just update this, right? So if I want to update it, so I'll just say that I have the things here. I have things here. Things. Now these things basically have a let's say device one. So in the things section, I have device one, which is IP enabled, right? Then I have device two, that is non-IP enabled. Okay. Now similarly, I have many devices. Now I want that it should communicate with the cloud. So in the cloud, I have IoT Hub. I'm adding it here, IoT Hub. So I must have IoT Hub here, in which I have a device management section. So there is a device management section that is called IoT devices. So device management section. Now, previously I was adding the devices here manually, but I wanted to automate it. So I will work with a service called DPS. So DPS service will be here. DPS service will be here. Device provisioning service will say that, okay, it has information about IoT hubs, with which it can where it can provision the devices. So let's say IoT Hub 1. So I'll make an entry here that there is an entry for IoT Hub 1, right? So it will say that, okay, I'm connected to this IoT hub. Second, it will have the information about the enrollment. It has a rules. Let's in simple, I can say rules. Rules will define uh, will define which device will provision on which IoT device, which IoT hub. So when the request will come to the DPS, it will decide that, okay, based on the rules, whether this device need to be provisioned in IoT Hub 1 or IoT Hub 2, which are related to it. And access policies, other things are also there, right? Which I can configure, which we'll talk later in the third module in more depth. And then IoT Hub will say that, okay, I'm a message broker. I'll collect the data and I can work with it. Message broker. And then it will forward the messages to the various services. Forward the messages to the services. So this is what it is. And then rest of the things will remain the same as we discussed at the top. Right. Okay. Now these IP enabled devices says that I might not want to send the data to the DPS or IoT hub directly. So I will configure the IoT hub gateway. Right. IoT hub gateway, where these devices can send the data and then I can process the data here. So I have a module 1, right, which says that after processing the data, it will going to call module 2. And finally, after processing the data, I will send it to the IoT hub using a device provisioning service. So this is the basic idea about it. So let's go with the slides. So learning objectives. In this module, we'll talk about describe the core components of Azure IoT solution architecture, describe the Azure IoT services and how they contribute to an IoT solutions, and then create an Azure account and see how it works with. So introduction to IoT solution architecture, as we discussed that the whole core subsystem of IoT architecture is divided into 3 parts: things, insight, and action. In the things part, we have a client side things like IoT devices. These basically are provisioned in the IoT hub, that is a cloud gateway, which provides the device management capability. And once they are provisioned, they can send the data to the cloud gateway, and that data is going to be processed by the various services, right, that are running in the cloud, like stream processing service, storage, right, service bus, UI and reporting tools. And further, the data is forwarded to the business integration or the business processing. So that is what they talk about. Now, this is what they have explained. Now, if you want to drill down into it, if you just drill down into it, so you can see that they further divided that. So on the things, devices can be IoT edge devices like IoT edge gateway, or it can be a IP enabled devices or non-IP enabled devices. So IP enabled devices or non-IP enabled devices can either communicate with the IoT edge device and then forward the data to them, and then using a short-term communication protocol, and then they can forward the data to the cloud gateway from IoT edge device. But if there is a IP enabled device, they can also send the data to the cloud gateway directly. Now here, device provisioning service, they have kept it in things, but it is on the cloud side, right? Why? Because it is a service running in the cloud, which has the ability to know that which device can be registered or managed in which IoT hub. And finally, when the message is received by the IoT hub, it can forward the messages for different processing. It can forward the messages for data transformation, and then it transform the data into a meaningful format and store that into the storage account, which is a warm path, means more frequently used data is stored there. As well as they can forward it to the stream processing service. From there, it can store the data to the cold path. Cold path means where the data is less frequently used. You can analyze it, and then you can even forward for different processing further, like machine learning and business integration. You can also use other services directly with the cloud gateway, right? That depends on your requirement to requirement, like service bus. Now, this is what they talk about, right? How it works. So data flow and processing, as we discussed, that an IoT solution is all about data because it collects the data from the devices. Why? Because it need to be processed on the cloud side. And then maybe the outcome of the data need to be returned back to the devices. So the flow is from things it goes to the Insight where it will be forwarded to the different services like storage. It will be forwarded to the services like service bus, depending on the routing configurations. And then you can analyze the data so that your actions can be performed. Action means you want to take some decisions on the data. So this is the flow that it works with. Now, if you go with the storage include different locations for different needs. So we have a different type of storage available. Like when we create a storage account, we have the option to work with the unstructured data like files, images, audios, videos. We can store the NoSQL data. We can store store the data into the queues and file share. So depending on my requirement, I can use the different type of storage. Routing is another capability. Let me see if any question is there. Okay, sorry. Let's see that there is some question. Okay, I missed questions because it is not there. I'm coming back to the questions. Just connecting multiple physical devices. Hand and systems are covered in it. Hand and systems, yes, it can. Hand and systems are like mobile devices, yes. Any device where you have configured your sensors, right? Yes, it can be a part of IoT devices. How is IoT traffic distinguished from regular internet? It is basically a way when you are creating an application, it has a connection string, valid connection string that goes to the IoT hub. And the payload is of a specific size, right? With the the content into it that can be like a key value pair, right? Because this is a JSON document which is serialized as a binary format and send it over the network. We have machines device communication without human intervention using regular internet too. Example would be helpful. Oh, clear difference with the example would be helpful. Without human intervention using regular internet too. No, you know, it is not about, I didn't get this question like regular internet too, because internet is nothing. Internet, what is internet? Internet is a group of servers, right? Where you are sending and working with the data. Here also we are working with the internet only, right? The only thing is that the data that I am sending, right, it is collected from the sensors and send it to the specific endpoint. That is the IoT hub for further processing, right? But when we talk about internet in which one device is calling the another device to get the data, let's say Google. So I search the data, it search the servers and get the data from it. So it is just presenting the data. But in the IoT, we are even processing the data and taking a decision on it. I'll take an example of, I have already given you an example of smart bulb. Another example of fan, right? I want to control the fan speed, right? Using a mobile. So how it can be done? That is basically checking the existing speed, existing temperature, and based on that, I can decide whether the fan speed has to be increased or decreased. Right, Bharat? Multi-speak to IoT. Yep.
Bharat here. Yeah. So yeah, I get it, and I can assume things, but I don't know. So that's why I asked this question. But my question would be: you gave an example of fan being controlled from the mobile, right? You don't need an internet connection to do that. A
Yes.
local VLAN connection would suffice, which would fall under intranet. Whereas
Okay.
you're speaking about when you say Internet of Things, I'm assuming that it's just going to be our our regular internet. By regular internet, what I'm trying to say is now you and I are communicating through internet.
Yes.
Correct.
Right.
So and we do have set up internet protocols and even messaging protocols for the matter to communicate with each other.
Exactly.
My question is, whereas with IoT we are calling it as Internet of Things as a separate entity, right? Otherwise, I'm assuming that again, this is just my assumption.
Sorry, your voice is breaking.
Okay, is it better?
Yeah, it is. It is.
Okay. Otherwise, the devices could very well use our own, internet infrastructure to communicate with the IoT hub, right?
Okay.
So what I'm trying to ask is, we have two sets of communication infrastructure, one for the things and one for our public internet. So how are
What is the
we
sound? Sorry, there is a lot of
distinguishing?
sound in between. I'm not able to.
I'm not sure. Let me go on mute.
I think somebody else is. Just give me a minute. Let me see. Participants. Okay, now it is. Can you unmute yourself, please?
Yeah, sure. Done.
Yeah. Please carry on.
Yeah. So that's why I'm still trying to wrap my head around why is it kept different, and I mean why is it termed different basically? Why are we calling the Internet of Things as Internet of Things? Like is it exclusive for just the sensors and signal processing infrastructure to communicate with each other, or how does it all work? The big
Okay.
picture, if you will.
The big picture, it is different because the main concept is to collect the data from the devices automatically, right? And passing it to some services for further processing and then getting the result back if required. That has to be automated, right? So if you are talking about anything which you need to uh, controlled over the internet, any devices that you want to control over the internet, right? By collecting the data and taking decisions on it, then you will go with, you call it IoT things, Internet of Things. But the first scenario that I missed because of the disturbance, so I'm sorry for that.
No worries, Sachin.
Please, I just
Yeah,
want
not,
you to
not yet, but yeah, I'll
repeat it.
collect my thoughts and write an email to you. I think that will be better. I don't want to consume more time. I
Yeah,
understand that we
please,
haven't
please do
like
that, because everybody knows that there was a huge disturbance in between. So I missed the things, right, what you were speaking. Right.
no
So
worries.
yeah. So the normal thing is that I'll just talk about, if you talk about the simple devices. So in that case, the servers are there and that server has the data that they're collecting, and then we have to make it available to the users, right? How we are making it to the users? By using a search engines, and then it is available to the users, and users are using it in their own way, right? But in the Internet of Things, it is designed for specific functionalities. So in this, there is basically the communication, one to one. There is a communication between the applications that is running on the device and the application that is running in the cloud. But how they will communicate? With the message pattern. So the message cannot be sent directly to the services, because the devices doesn't know anything about the backend application, and backend application does not know anything about the devices. So there is an intermediator called IoT Hub. IoT Hub says that I am the one which can collect millions of the messages. I am the one which can store millions of the messages coming from different devices. Those devices can send the messages directly to me if they're IP enabled, or they can work with the intermediator called IoT Hub Gateway. And then it can send the messages to me, which I can forward to the services for further processing. And then these services can send the result back to me, and I will forward to the devices. Now I'll take an example of a plane. Like you are sitting in a plane, but plane is still at the airport. So you have a direct connectivity to the internet. Your devices has a connectivity to the internet, and they are collecting some data from the nearby system and send it to the IoT hub. Not a problem. But let's say your flight took your flight take off, and then you are at a height where there is no internet, but your device is still collecting the data, and you want to process the data, right? So how it will send it to the IoT hub? In that case, I will configure the IoT hub gateway. That is a big server which is configured in the plane, which has some modules running into it. Modules is a code running into it. And my devices can connect to that gateway, and whatever data they have collected, they can send it to the gateway. This gateway will store the data till the moment it gets connected to the internet. And as soon as it connects to the internet, all the data that it has stored will be forwarded, and IoT hub will process it and forward it to the services. But because there is no internet, so they can use a short-term communication protocol to send the data to the IoT hub gateway. I hope that scenario will make little sense. So that's what we were talking about. Now routing, as we say that now one device can have many sensors, right? Let's say one sensor is collecting the humidity, another sensor is collecting the GPS, third sensor is collecting something else. So when they collect the data and send it to the IoT hub, so IoT hub can basically check the content of the message, and based on that, it can route the messages to the respected services. So I have the capability of routing. Analysis. So transform input to output to produce insight while maintaining the original data. So in this case, we have the stream analytics service, which says that I will get all the data that is coming into the IoT hub, or maybe I can filter the data based on the query, and then I will process it and forward it to the output. That is maybe a Power BI for analysis. So it just get the copy of the data, process it and forward it to the other services so that you can take an action on it. Action is basically you want to, and maybe you want to analyze the data, or you want to take a decision that, okay, if this is the condition, this is the data that I got, then what I want to do next. Maybe I want to slow down the car. Maybe I want to apply a brake, right? Or maybe I want to change the gear. So all these things can be done automatically after analyzing the data that it has received from internet. So this is the cross-cutting edges as I was talking about. So every application that you create needs a security, needs a logging and monitoring, and high availability and disaster recovery. Either I can have that whole implementation written in my IoT solution, but if it is, then if another application needs the same functionality, so I have to recreate that for that solution. So Azure has created or worked with the services independently. They say that I have configured security, logging and monitoring, high availability and disaster recovery as a separate service. You can integrate it with your IoT solution whenever you need. So it is a concept of defined once and use multiple times where you want to work with. So you don't have to write a complete logic of security because this service is created and integrated with it. You just have to configure it for your solution and you have to use it. So that's what they talk about. I'll show you one IoT hub that I have created in the morning batch. So if I go to this particular resource, that is a resource group. And this is IoT hub that I have created. So in this IoT hub, when you create that, you will see there is a monitoring section, matrix, diagnostics, logs are there. Then there is a security part here. So if you look into the shared access policies, so you can configure the policies here, right? So if you are adding a policy, these are the permissions that you can add: registry read, registry write, service connect, device connect. So all these permissions are there that you can choose. So whenever you create a policy, so this policy has full rights. Service is only for service connect. Now every policy that you click on that, it will have a connection string. So I can give this connection string to my developers, and developers can use this connection string to communicate with IoT hub with the respected rights. Right. So it has inbuilt security. I have not created it. I'm just configuring it. So no matter how many IoT hubs I'm creating, I'll get the same feature into it. I just have to consume that by configuring it. So that's what cross-cutting edges are all about. IoT hardware in the cloud services. So IoT devices can be IP enabled or non-IP enabled devices. IP enabled devices can communicate with the IoT hub using internet directly, but non-IP enabled devices, how they will communicate or send their sensors data to the IoT hub. They say that we will use short-term communication protocol like Bluetooth to send the devices which are running in the same network, right? And then those devices, after collecting the data, can connect to the internet and forward that request to the servers. So here there is an example. I'll show you one thing. So here I'll go to Philips IoT bulb. So if you look into the Philips IoT bulb image, so here previously they used this device, right? You can see these are the IoT bulbs, but they don't have the internet connectivity within. So they use the short-term communication protocol to send the data to this device. This device has an internet connectivity. So this device can collect the data from these bulbs and send it to the internet for further processing. And whatever the instructions it gets from the backend application from the internet, it forwards that messages to the bulbs that switch on, switch off, and light change color and everything. But nowadays, my bulbs are smart bulbs, right? Which do not need even this editor, this particular tool, because they are IP enabled, though they can send the data directly to the cloud and get the data from the cloud. So all the logic, application logic, is also registered here. So that's basically an example of it. Now, if you are working with this, if you are working with this concept, right? So if you want to manage the applications that are running onto the device, or if you are creating an application that is running on the devices, right? Then you have to use the device SDK. You have to use the device SDK. You have to download the device SDK, right? Which contain the classes that allows you to write a program that runs on the devices, right? That allow you to collect the data and send it to the IoT hub. If you want to manage the DPS, like if you want to manually, if you want to write a logic to create the IoT hubs registered with that rules and everything, then either you can do it graphically with the CLI or with the code. If you want to work with the code, then we have a DPS SDK, device provisioning SDK, device provisioning SDK is there. Last but not the least, if you want to create a backend applications, so the backend applications are here. Let's say backend applications. If you want to work with the backend applications that can collect the data from the IoT hub and want to process the data, right, and then send the data back to the IoT hub. So in that case, you can use the service SDK. So there's the third type of library that you can download. That is service SDK. So these are the three SDKs that you will be using depending on where your application is running and what it is doing. So let's continue further. So we have talked about IoT devices, we have talked about IoT edge devices, and other IoT hardwares are there that I've shown it to you, like IoT Philips bulb. Now, IoT central service. As we discussed that if you are working with the PaaS service, platform as a service, so you are working with the IoT hub independently, device provisioning service, right, stream analytics service, everything you are doing it independently. You are working with each and every service manually. So you have a full control on it, but it will take time. If you want to rapidly create your IoT solution, then they gave you a software as a service that is called IoT Central. When you open the IoT Central, it is a browser-based way of configuring your IoT solutions, where you will get a template to work with retails. If you want to create an application for retails, health, energy, government, so you have a different templates for that. Otherwise, you can start creating your own blank template, and graphically, you can decide that what type of devices can connect to the IoT hub, right? What type of data they will send, what type of actions they can perform. Everything you can do it graphically from the browser. But obviously, it has a less control on the infrastructure, right? But yes, you will get the things much more faster. So all these capabilities will be available. And in the 11th module, we're going to dig into a little bit more. So this is what we have already discussed, Microsoft offerings. Device softwares, if you want to install the softwares right onto the devices, so you should know what operating system it supports. So it will not going to hold the devices that you are working with, right? It must be lightweight. They should have a long battery lifetime, and that is possible if they just have what they need. So we will not going to install Windows 10 on it. We have a Windows 10 IoT version of operating system that we can install on that. We can go with Ubuntu Core. We can work with the Riot, QNA, Android automotives. So depending on what type of device we are working with, we have a different OS support for them. So in the book, which you will be getting, they have little explanation about it, which operating system to use on which type of devices. Android automotive is basically used where you are working with the like self-driven cars, right? You can use this type of operating system on that. Programming languages. Now you want to create an applications that will run on those devices. So the applications can be created in languages like C, C++, Java, C#, Python, etc., PHP, right? And to work with that, we have SDKs, device SDK, service SDK, and device provisioning SDK. So these are the three SDKs that you will be working with. And again, they came up on the same part. Now, cloud gateway. So they are just explaining what cloud gateway is. I told you that cloud gateway is here, which gives you the device management and message broker, as well as whatever devices can call to it, it securely allow them to talk to the IoT hub. So each device can prove its own identity. So that's the capability. Security is there, right? Scalability is there. You can change the plans, right, to accept more messages, right, in a particular day. Routing capabilities there. You can integrate with different services. You can manage the devices which can send the data to the IoT hub. You can monitor what is happening into the IoT hub. How many devices are connected? How much messages are sent? How many messages are failed? Right? All this information can be monitored. Then comes your device provisioning service. Third module is on that. So device provisioning service has the, first of all, multi-hub support. Means it says that I act as an intermediator. So I can provision the devices on IoT hubs, different IoT hubs based on the rules. And those rules are defined in the enrollment list section. In the enrollment list, it contains the rules that if any request comes, if it has this type of information, which IoT hub it will going to be deployed on, so that you can talk to that device can talk to that IoT hub. Allocation policies are there, right? That when the device is re-provisioned again, then what happens to the existing information data? So that is also configurable. And secure attestation. Every device need to be authenticated. So we have a different way of authentication, right? I can go with the symmetry key. I can go with the certificate, hardware security module. We'll talk more on that when the topic comes. So that's the end of the first module. In the first module, we just get an overview of the architecture, right? Now, second module is all about IoT Hub, where I will show you the practical implementation of IoT Hub, how to create it, how we can connect to it, and how we can send the data. So there is a lab scenario in that they are just asking you to look into it, right? Monitor product temperature and humidity in the factory and warehouse, monitor vehicles during shipping, support factory equipment. So there is just a concept that they're trying to talk about. Now, when labs, how to perform the labs? That is the question. So to perform the labs, the very first thing is that you need to have the, what do you need to have? You need to have a valid Azure subscription. So I'm going to share few steps with you, right? That you have to follow if you want to create your, you know, get the book and Azure Pass. I'll tell you what it is. So I'm pasting this details into the chat, and please keep it with you. Sorry. So these are the steps that I have shared it with you. The first step is to redeem the book, right? So maybe at the end of the day, you will get two types of codes. One is a DMOC code and another is Azure Pass. So the DMOC code is for the book. So for that, you have to go to Google, and then here you have to type skillpipe.com. As I have already mentioned in the first step, right? Redeem the book, skillpipe.com. When you open it for the first time, you have to click on join now. Give the first name, last name, and use your personal email ID, because this book will be there with you for long time, So use your personal email ID and then give a random password for this and register yourself. Once you register, you can log in into it. You have to log in into it. And once you are logged in, you will click on these three dots and click on add course. You will paste that DMOC code that you will be getting and click on redeem license key. Once you redeem it, you have to accept the license, and at last your book will be available in your bookshelf. Go to the bookshelf, and then you can click on the book, whatever book you have, right? You will click on that, and then if it is for the first time you are opening, it will ask you for accepting the license. And once you accept the license, then you will get the table of contents. You can click on that and see the content of it. Right, you can read the content, whatever is there. Whatever I'm showing you this, whatever slides I'm showing you to you, they are available as this, and then its explanation is there. So this is what the book is all about. Let's see what Was the message trimmed? I know the message is not trimmed. Which message you're talking about? Karan, please let me know which message you're talking about. Hello? I didn't get it, Karan. Can you explain that? You can unmute yourself. The message you just pasted in chat. I'm not sure because I can see everything, right? If you look into it, right? So open the URL skillpipe.com. If you don't have an account, right, you fill the details. Once you have an account, log in into the site. Everything is there. No, it is not trimmed. Everything is there. If you want, I can paste it again. I have pasted the steps again, right? Okay, now next thing is that redeem an Azure pass. So there is a link that I have given that you can get it even from here, google.com. You just say redeem Azure pass. And when you click on that, it will take you to the page called microsoftazurepass.com. Now here, don't use your official ID, right? Because sometimes official account has some restrictions. So create a new Outlook account for you, because when you are redeeming your Azure pass, it is only for 1 month and you will get $100 credited into it. So you have to sign in with that account. Once you sign in with that account, right, then the sign in button will be changed here to confirm Microsoft account. When you click on it here, you will paste that Azure promo code. Click on claim promo code and then you fill the form. And when you fill the form and at last, once everything is done, it will take you to this page, home page, right? So you have a valid subscription. If you click subscriptions, you will find the name of the subscription called Azure Pass and you will see it is active. And then you need to perform the labs. How to perform the labs? Now, if you want to perform the labs, what you have to do is you have to go to Google and type AZ220 GitHub. And here, the first link, I'll share this link even. Now, the laptop on which you want to work with it, where you have a full permissions, right? You can perform this. You can download that Git repository there. If you don't have permission on your laptop to install the softwares, you can create a new virtual machine in the cloud, right? With Windows 10 operating system, or you can go with the Visual Studio 2019 template. Once it is created within that virtual machine, you can open that link and then download this as a zip file. So your machine will have all these files available. Now, in this file, you go to the instructions and you can see labs and you click on the first one, getting started. You click on that and follow the instructions, whatever they are mentioning it. What you have to do, you have to follow that. Similarly, lab 2, you can click on that. You will do the labs accordingly. And if you want to know what you want to install into that machine, so at any point of time, you go to that root folder and you can see lab.md. In the lab.md file, these are the softwares that you need to have, right, into your machine to work with it. So you can just find the links and click on it and then install those piece of softwares from there. This is how you will be performing the labs. I will give you the link of this GitHub repository so that you can work on this whenever you want. So this is a GitHub repository. So we are done with the very first module, right, for today. Now, there are some questions that they have added. So there are some questions that you can answer, right, to check the progress, that how we are doing it. So please choose the one best answer and put that into the chat window. What do you think the best answer would be? D, okay. Everybody saying D. Let's see. What other says? Okay, so you are all saying D, like it gathers input value from connected sensors and send telemetric to the cloud. Yes, it is one of the functionality, right? But it also does that. You can say it provides secure connectivity, telemetry, and event ingestion and device management capability, right? So the answer is B, right? So I say best answer. See, D is also correct, but B is much more appropriate, right? Great, guys. So you're right. B is the right answer. Now let's go with the second one. So here you have to choose the second answer. You have to choose this one. So choose the best answer, right? D. Okay. Security associated with all subsystems of the solution and should appear across the top of the diagram. Yes. Answer is D, because it is a cross-cutting edge, defined once and used with multiple resources. Right. So you say that security is associated primarily with communication between the cloud gateway and other services and should appear next to the cloud gateway on the diagram. No, not to the next to the cloud gateway. It is at the top of that environment because it is a security. It is a basically a cross-cutting edge, right? So answer is D. Okay. Next, we'll go with the third one. Choose one best answer for it. Very simple and straightforward. So, okay. Amit says D. What about others? Okay. Srishti says D. Nisha says D. Whose is A? C. Answer is D. Reason behind it, because you can see that it says that your team is small and will need a fully managed SaaS solution, software as a service solution, that can be started quickly and operated with minimal IoT experience. So I want to go with a software as a service, that is IoT Central, right? IoT Central is a SaaS service. If you remember, I have explained that in the beginning, that 11th module, we're going to talk about IoT Central, which is a software as a service, where everything is configured from the browser. You have a limited control on it, but yes, things will be created quickly. So answer is D. Now, this is the question. Please let me know about that. So there are two questions left, one this and next one. Okay. Which of the following features of IoT Hub? What IoT Hub will do it for you? So choose all correct answers. A, C, D. Okay. Half of the answer is correct. So first thing which I would like to tell you, that it has IoT Hub has nothing to do with the resource group, right? So answer is B, C, and D. B, yes, it provides the authentication, right, with the certificates, right, or with the other type of authentication mechanism like symmetric keys. As well as it has a capability to route the messages to different endpoints, like different services. And last, enable storage enable storage. You can store the data there for 7 days, as I was talking about. Synchronization and query of the device metadata. So it can check which devices has sent the request, and based on that, it will decide what to do with it. So answer is B, C, and D. The last question is on your way. Now, this is the last question where you have to perform the Choose all correct answers. What device provisioning service is doing it for you? I know that it will come in the next third module, but we have just talked about it. So if you can provide the answer. Okay, BC. So as we discussed that it provides you secure attestation support, right? Let's see that. Just I'll take you to this, and you can see that it shows you that what you can do. Secure attestation is there, enrollment list is there, allocation policy is there, monitoring is there, multi-hub support is there, and multi-hub means hubs available in different regions, even they can work with it. So here, if you look into it, so secure attestation support for both certificate and TPM based identity, yes. Multiple allocation policies, yes. Multi-hub support as well as cross region support. So answer are all right. So answer is A, B, C, D. Multi-hub support is also there, right? So when we talk about third module, then things will be much more clearer to you. So that's end of the first module, right? What we have covered. Now we are left with the next module, right? So before moving into the next module, let me just open that and tell you what is coming into your way. And if you want, we can take a short break of 10 minutes, right? And then we can continue. Or if you want to continue, I'm happy with that also. So module 2 is more on the practical side, which I will be working on. So it is all about your device and device communications, right? So how it works, right? Devices and how the devices communicate, and it is basically going to talk about topics like the core features of IoT Hub services, life cycle of an IoT device, and how the IoT Hub manages the device identity and implement the securities, how we can work with IoT Hub with the portal, CLI, and Visual Studio Code, and about the SDKs. So these are the topics that we need to cover. So please let me know, would you like to take a break or you want to continue? Yes. So you can type if you need a break or continue. A break, please. What about others? Okay. So we'll take a exact 10 minutes break, and I will start exactly after 10 minutes. So I'm starting a timer, and it is for 10 minutes. So here time starts now. So enjoy your break, and we'll see each other after exactly 10 minutes. I'm back, guys. Please confirm those who are back. Great. Seven, 8, 9, 10. Okay, 11, 12, 13. 13. What about others? Okay, 14, 15, 16, 17, 18, 19. 19 out of 43. Okay, 20. Good. So at least most of you are back. So let's thank you. Thanks for joining again on time. So we will continue with the next topic, right? That is the second topic for today. And in that topic, I'm going to talk about the device capabilities, that how the devices can communicate with each other, right? How to register the devices and so on. So mainly it is all about IoT Hub. And I'll show you the practical of it also. So from this module, I'll try to show you a practical. So the first lesson that we will going to talk about is the IoT Hub. In the module 2, the first thing is all about IoT Hub concept. IoT Hub concept. Now, whenever we want to create an IoT Hub, right, in an IoT solution, we have to keep in mind that what are the capabilities of IoT Hub we need. So every IoT Hub or IoT solution is different, as we know that. Depending on the requirement of the client, I have to make a new solution with the different capabilities into. So Azure IoT Hub offers different capabilities, different capabilities. Now, which capability I will get? Now, which capability I will get? Right. It depends on the basic depends on the plan or tier I'm using. Based on the plan or tier I am selecting. Now, as we'll talk about what capabilities it provides, but the plan that we will going to choose will also help me out to choose the capabilities. So to evaluate which plan I need to use, I need to use, right? We can think about two things. The first is the what features I need. What features or capability I need. Capability or capabilities I need in IoT solution. Second, how much data I am planning to move daily. How much data I am planning to move daily. Means how much data I'm expecting that my IoT hub will get from the devices, right? So based on these two things, I will choose a respected plan or the tier. Now, there are three plans. There are three plans which from which I can choose one. From which I can choose one. The first one is a free plan, free plan. Second one is a basic plan, and the third one is a standard plan. Standard plan. Now, in terms of capabilities, in terms of features, right? In terms of features that it will provide to IoT Hub is same as standard, plan, but with limitations, I will talk about those limitations. Now, basic plan comes with 3 editions. So it comes with 3 editions. So, or I can say that basic plan has less capabilities as compared to standard plan. It comes with 3 editions. The first one is B1, B2, and B3. Standard plan, it provides all the capabilities of IoT Hub. It provides all the capabilities of IoT Hub. Or it also comes with 3 editions. It also comes with 3 editions. The first one is S1, S2, and S3. Now, the only difference between the basic plan and the standard plan is about capabilities, right? If you think about B1 and S1, the only capabilities are different, but the amount of data they are sending over the network, right, will remain the same, right? So I'll talk about that. So what capabilities, right? What capabilities are there? So I'll just take you to the slide or maybe to the internet to explain that, because in that I'll show you the capabilities. Otherwise, it is on the slide also. So capabilities of IoT Hub. So if you're working with the capabilities, let's see if I can see that here. Otherwise, I have to go from the portal itself. No, I'll go with the portal. Just give me a minute. I'll show you the capabilities that I need. I'll come back to this. Don't worry about it. Okay. Let me go back from here. Not a problem. I'll come back. Okay. So you can see that whenever you are creating an IoT Hub says that I'll give you the ability to send the device data from devices to the cloud. I can validate each and individual device. I have the capability of message routing, means when message is received, I can forward to different endpoints based on the conditions. Message enrichment is there, means if you have sent a message with temperature and humidity, but I want some extra information, so I can customize the message and then forward it to the destination. I can do that. I can integrate with Event Grid. The protocols that are supported, right, are HTTP, AMQP, or MQTT protocols. Device provisioning service, monitoring and diagnostics. If you want to send the data from the device, from the cloud to the device, right, that is possible. Device twin, we'll talk about it. What are those? Module twins, device management, device stream preview, Azure IoT Edge, IoT plug and play. So these are the capabilities that are provided by IoT Hub. But if you're working with a basic tier, no matter what edition, B1, B2, B3, no matter what edition, you can only get the first few capabilities. So question can come accordingly. So device to cloud telemetry, per device identity, message routing, message enrichment, event grid, protocols, device provisioning service, and monitoring and diagnostics. These are the only capabilities available in basic. But if you go with the free or standard tier, you will get other capabilities like cloud to device, device twin, module twin, device stream, Azure IoT Edge, and IoT plug and play. So these are some extra capabilities that you will be getting when you go with the standard one. Now, what is the addition inside? Right, that is something that I would like to talk about. So addition defines that how much messages can be sent per day, and what is the maximum of amount of data that can be sent in one day. That can be defined by these plans. So if you're using a B1 edition, B1 edition says that you can only send 400,000 messages per day. Right. Same thing is with S1 tier. B2 says that you can send 6 million messages, 6 million messages per day. And same is for the S2 tier. And the B3 is 300 million messages, 300 million messages per day. And here, same with S3 with extra capabilities, right? That I was talking about. One way, yes, the basic is one way, you can say that. Okay, so these are the capabilities that you're getting, as well as in B1, B2, and S1 and S2. It basically all works with the units. Unit is like you can say a channel, or let's say a lane, right? Where or a pipe in which message can be sent, right? So it is per unit, per day, per unit, right? Per day, per unit, right? Per day, per unit, right? That is an extra thing which I would like to add with every single statement. Now, if you are in B1, B2 or S1 and S2, right? In this, you can purchase maximum 200 units. You can purchase total 200 units if you want. 200 units can be purchased if you are in the B1, B2 or S1 and S2. So units. And if you are in the 300 million like B3 or S3, in this you can purchase maximum 10 units because one unit has enough amount of messages. So maximum 10 units you can go with. Same with here. So if I say that B1 is taking, one unit is taking 400 messages, 400,000 messages. So if I go with the 2 units, so how many messages it can send? 400,000 into 2 means 8 lakh messages per 8 lakh messages per day for 2 units. If I buy 3 units, means 400,000 into 3 means 12 lakh messages per day, right? Similarly, if I say 6 million messages for one unit, if I buy 2 units, means it will take 12 million messages per day for 2 units, right? That it works with. And here 300 million messages, if I go with 2 units, it will means that it will go with the 600 million messages for 2 units. So you can easily imagine that how many messages you can send. So this is what it is. Now, when I created a IoT hub, if I created a IoT hub using a basic plan, right? Basic plan with any of the option, I can upgrade it to standard plan at any time. But if I have created an IoT hub with a standard plan, I cannot downgrade to basic plan. No, it is not possible. But yes, within the additions, I can switch. If I have created a standard S3, I can switch it back to S2 or S1, and from S1 to S2 and S3. And same with the basic plan, B3 to B2, B1, or B1 to B2 and B3. Right? In free plan, we cannot upgrade to basic or standard. So this is something that we can work on. So we can only upgrade from, sorry, my fault, upgrade from basic to standard plan, but downgrade from standard to basic is not allowed. is not allowed. We can upgrade or downgrade. Downgrade within a plan, within additions of a specific plan. Specific plan. So these are the key things that we need to understand. Now, another important point, the message size. So the maximum message size is 256 KB. 256 KB, right? 256 KB, and it is delivered in chunks of 0.5 KB, 0.5 KB, right? And in case of basic and standard tier, right? In case of basic and standard tier, the maximum size is 256 KB, but the chunk size will be 4 KB. So in case of basic and standard tier, the maximum size of message is still 256 KB, but the chunk size will be 4 KB. Now, what does it mean? It means that if I have a message of, let's say 8 KB that I want to send to free tier of IoT Hub, then it will going to create because I say it will be sent as a 0.5 KB of the message, right? So how many messages required? Means 16 messages, right? Because one message will be divided into 2 messages. So 8 KB message, 1 KB message is divided into two messages of 0.5 KB. So 8 means 16 KB. So going to create 16 messages of 0.5 KB each, and I will be charged for 16 messages, right? It will be treated as 16 messages, right? And if I just copy that and paste it here, if I have to send, let's say 8 KB message KB that I want to send using a basic or standard tier of IoT Hub, then I told you that the size of the message will be 4 KB, right? 4 KB. So how many messages are required? If you want to send 8 KB, 8 KB divided by 4 means 2 messages will be generated to send a 8 KB of data. So 2 messages of 4 KB each are sent. So you will be charged for 2 messages, right? So this is the difference between the free tier and the basic and the standard tier. So that's what it is. Now let's talk about the units, right? So there can be a question that can come. Let's say you have to send, let's say 20 million messages or 2 million messages, right? 2 million messages. So, or let's forget about 2 million, make it simple. Let's say you have to send 12 lakh messages, right? So which option you will go with? So if you know that B1, B2, B3 or S1, S2, S3, the pricing difference is high, right? So there are 2 options. If you go with B1, you only send 400,000 messages. If you go to B2, 6 million messages can be sent, means 600,000, 60 lakh messages can be sent. But I want to send 12 lakh messages. So why to reserve B2? Why not to purchase another unit of it? So B1 with 2 units, because 8 lakh messages. No, 2 units will not sufficient. So 3 units, right? So 3 units of B1 allow me to send 12 lakh messages. So that's sufficient for me. And it is much more cheaper than what I go with the 1 unit of B2, right? And same with this. So units will decide that how much messages I can send over the network, right, per day. And increasing the unit will always be better than in changing the addition, right? So that's what this module is all about in first section of it. So let's see that practically. So I am into my Azure and I want to create an IoT hub. So what I'll do is I'll click on create a resource. For that, the first thing that I need is to choose the template that I need. So I'll click on IoT hub. I can search it here or I can find it in Internet of Things in this category. I click on IoT hub and the IoT hub says that, okay, would you like to create it? If you want to see the plans, usage informations, it will give you the complete information, documentation, pricing, scale, everything you can get it here. Now click on create. Whenever you click create, it will open a template where you have to specify the settings in which resource group. So I will create a new resource group where I would like to keep this information. So I'll just say that AZ220 Feb RG. That's what I have defined, right? And I click OK. So this is the resource group where I want to create a IoT hub in East US region with the name called My IoT Hub Demo. Let's see its name. It is yes, it is available. Globally unique. It has to be globally unique. It is available. Go to the networking. It can be accessible from anywhere. Now the main thing comes in the management tab. In the management tab, I have a plans. You can see that free tier, B1, B2, B3, S1, S2, S3. If you choose free one, so you cannot purchase the units. Only one unit is there. And you can have only 8,000 messages per day that can be delivered of 0.5 KB size each. And that's it, right? And you will get all the capabilities of standard. Otherwise, you can go with the B1 tier. So when you choose B1, you can see that in the B1, maximum unit you can purchase is 200. And each unit basically allow you to send 400,000 messages, right? That you can work with. So you can see that cloud to device command only available in free and standard. IoT Edge only available in free and standard. Device management only available in standard. So these three, like these capabilities are not there. But if you move to S1, B1 or S1, everything is same. Purchase maximum 200 units, right? Each unit will allow you to work with 400,000 messages, right? And here, cloud to device command, IoT Edge, device management, these are enabled by default. So some extra capabilities are there, right? So the price for this 1 unit of S1 is 1801 because of these extra capability. If you go with a B1, you have only 720 rupees per month, right? For same messages because it is not having those capabilities. Now, if you go to the B2, so the B2, the price for B2 for 60 million messages is 3600 rupees, right? And you are sending 6 million messages. Now you can see that if I go to B1 and I was talking about that I need 3 units of it because I need to send 12 lakh messages. So I can just type let's say 3. So I can send 12 lakh messages and it is just costing me 2,161, right? So I'm still saving the extra piece of money that I can paid for B2, right? Which is useless. So I have to think about how much data I need to send. And based on that, I have to decide that what capabilities I need. And based on that, I will choose S1 or as standard tier or basic tier. And then how many units I need to purchase of which unit, of which particular edition. Does it make sense, guys? So the default setting, if you default setting is S1. If you're not specifying any setting, by default, it will use S1 standard tier. And I'm happy with that. I'll click on review and create. So I'm going to create a new IoT hub with that setting. Please let me know because it will take few minutes to create. Please let me know if you have any question. Yes. Free OS recommended? I didn't get it. OS recommended means? Free one, like if free one is for testing, right? You go with the free one with the testing because it has a limitation of like maximum, I think 500 devices can be connected. So it has a limitation. So it is only for the free tier is only for the testing environment, not for the production. I hope you are talking about the same one, right? Okay. Any other question? Now, whatever I'm doing it here, I can also do it with the CLI or with the SDK, software development kit. So I'm going to show you with the steps. Yes, all the labs in GitHub can be performed using free tier. Free tier. Okay, you're talking about two things: free account, right? Like Azure Pass. If you're talking about free Azure Pass that I have given it to you, yes, you can do it. But when you are doing this IoT Hub, you have to create a standard one, S1. Money will be deducted from the $100 that is credited to your account. So in the lab only they will tell you that create an IoT hub with this plan S1, right, or S2. So everything is very well documented. Okay, so till the moment it is creating, let's go with the slide now. So if I go with the slides, so the first thing is all about core features of IoT hub. So we discussed that IoT hub capabilities are differentiated by tiers, and we have 3 tiers: free, standard, and basic tier. We have discussed about the difference between the tiers. So free tier and standard tier provide you the same capability. Basic tier has a limited capability, like it is one way. IoT Edge is not defined there. It is not allowed, right? Okay. Standard is the full-fledged IoT hub with all the capabilities. And these are the capabilities that I was talking about. We have discussed that capabilities. So in the free and standard tier, cloud to device messaging, device twin, module twin, device management, device stream, Azure IoT hub, IoT Edge, sorry, IoT plug and play. These capabilities are missing in the basic tier. Okay, let's continue further with the IoT hub throughputs. So I was talking about additions. So no matter whether you are working with the basic tier or standard tier, they come up with the 3 additions: B1, B2, B3, S1, S2, S3. B1, B2, B3, and S1, S2, S3 are differentiated in the capabilities. But B1 and S1 are same in terms of total number of units that you can purchase, the amount of data they can send per day. Right, that is the only difference. Otherwise, the capabilities are different, right? If you go with B2 and S2, the capabilities are different, but amount of data they can send per day, the total number of messages they can send are exactly the same. Same with S3 and B3. We can upgrade or downgrade additions at some time. Additions, they are not talking about tiers, right? So when we talk about upgrade a tier, we can upgrade the tier from basic to standard, but downgrade of tier is not allowed. But we can upgrade or downgrade the additions at any time, as we have discussed. Within an additions, we can pay for certain number of units. So by default, B1, B2, S1, and S2, we have 1 unit default, but we can purchase maximum 200 units. And in S3 and B3, we can purchase maximum 10 units. Auto scaling. Auto scaling is a concept where we are changing the additions or we are changing the tier from basic to standard. There is no way by which I can configure it graphically. If I want that, I have to create an Azure function and I have to implement the logic there, that when and how the logic app, when and how the scaling will be performed, right? So it is an extra thing that I have to configure. It is not a part of that service. So this is what I talked about, B1 and S1. If you are using any of them, the capabilities are different, but how many messages, what is the maximum size of data that you can send per minute per unit, right? 1111 KB of the messages can be sent per minute per unit. And in total, you can send 1.5 GB data per day per unit. And here 400 messages, 400,000 messages per day per unit can be sent. And if you go with B2S2, second edition, up to 16 MB per minute per units can be sent. In total, 22.8 GB per day per unit can be sent, and 6 million messages per day can be sent. And the size of the message will be 4 KB, right? So it will divide your message, one big message, into that particular chunk and send it over the network. Okay. Usually cloud products are built flexibly per consumption or resources. Does Azure IoT follow? No, it will work with a fixed billing. Like, because when I created a B1 or S1, it will going to charge you, like B1 one unit will charge you 700 rupees per month. So that is fixed, right? Because it says that I'm expecting 400,000 messages. You send one or two or maybe all, right? It hardly matters, but you have reserved that space. Right? I hope it makes sense.
Yeah, got it. Thank you, sir.
You're welcome.
Yeah,
So this is what the plan is all about, and additions are all about. So now the next thing is that endpoints I was talking about, the capabilities. So the IoT Hub provides the different capabilities. Yes.
Sorry to interrupt, Sachin. Just one follow-up question on that. And you said that the downgrade is not possible, right?
Yes.
There might be instances where for a few months the capacity that is needed might be low compared to the other months, right? There are few case studies of that. Mm-hmm. So in those cases, do we have no option but to pay for the
new one
share that we have? Yeah.
So there is no way. Yeah, right. You can see that if you go to the resource, I'll show you practically. If I went into the IoT Hub, right? When I'm into the IoT Hub, you can see that I have here the pricing scale. I have used S1 plan, right? It will show you that S1 plan. And if I say that I want to scale it, so there is no way to downgrade it, right? It's not allowed. So you have to delete it and recreate it if you want that. Okay.
Okay. So all the resources and all the data that we have accumulated with the plan will also be deleted.
Exactly.
Okay. Okay.
But yes, if you have choose basic plan can be upgraded to the new one, a standard one. That is possible. But downgrade is not possible. Downgrade is only possible within addition. Like I have selected S3, I can move it to S2 or S1, S1 to S2. So within a tier, I can move to and fro. Okay, so there was another question that is in the chat, that is, if you use one unit for 3 days, do you still pay for the month? No, it will be calculated accordingly. No, it will be calculated accordingly. How much, for how long you are using that unit, right? That is pay as you go. Okay, now let's continue with the practical that I was showing it to you. So here, this is my IoT Hub. I have created it, and I told you that pricing and scale, you can upgrade and degrade, you can buy more units, right? Now the thing is that I want to work with the device management. So I told you that my IoT Hub supports the device management. So if you want to work with the device management, you need to connect to this IoT Hub. If you want to connect to this IoT Hub, you must be a trusted user, right? So for that, I have a shared access policies. So in the shared access policies, when you click add, you can see the permissions are registry read, registry write. So this registry is your IoT devices and IoT edge devices, where you can register your devices. So this area, would you like to read the data from there or write the data to? So you can grant permissions. Service connect, if I give this permission to anyone, so they can connect to the IoT Hub and work with it, view the content or send the data to it, right? It is all about sending and reading the data. Device connect, so devices can only connect to this IoT Hub. So these are the permissions that I can work with. Now here they have created the policies. So when you create a policy, every policy has a name with the permissions. So when you create that, you will see that every time policy is created, you click on that policy, it will have a connection string. So I will give this connection string to the users, right? Or the developers, and the developers can use it in their application to work with it accordingly. So I'm just copying it because I will be using it in my demonstration. So I keep it right, or maybe I can leave it. I'll copy it whenever I need it in future. Okay, so these are the policies. Now let's say I logged in as an administrator and I have full permissions. So I'll go to the IoT devices. Now this IoT says that which devices can communicate. So I will make an entry here, new device. I give it a name, device one. Now I say that any device, if they want to communicate with me, they can use the symmetry keys that are defined here, which are auto generated. But in real world, these keys are provided by the manufacturer of the device, right? So I will get that, or I can get a certificate. So any request that comes must have the certificate that I will upload it here. And then I click on save. Certificate can be self-signed or it can be signed by the trusted authority. And then I can work with it. I can click save. So in this IoT hub, I have created one device entry. So this device entry, when I click on that, you will see that it has its own connection string. This connection string. Right. Now let's copy this connection string. Now, how I need to test, right, that whether this IoT hub is getting the data, right? I don't have a physical device. So I will work with the emulator, right, or simulator. So here I have opened the simulator for Raspberry Pi. You go to Google, search for Raspberry Pi simulator, and it will open that screen. Now this is a controller having sensor in it, and this will show you the lid, which whether it is connected or not. Now what I did is, let me refresh that. So when I did that, this is a code that is running on that device. Here it is asking me the connection string. So I will paste that connection string of that device that I have copied. So this connection string, I'm using it in my to create a device client, and that device client is taking this data, right, and sending it. So when this request reaches to the IoT Hub will validate that, okay, this request is coming from a device, right, which is having this access key. There is an access key, right? This is a key, and this key is the one that you have defined it here in that connection string. This one. So this and this. So this is the key that is defined this. So it matches, means it is coming from trusted source. If it is coming trusted source, so I will allow that device to connect to me and then send the data. So I'm in the overview section of this and of the IoT Hub, and you can see that there is a monitoring utility, IoT Hub usage. So let me refresh this. Why it is showing? Okay. Okay. Total IoT devices. So it is showing you one because it is connected. Let me just click on setting last 1 hour and refresh it. So it takes time. Or let's just give me a minute. Just be with me. Resource group, AZ220 Feb, and my IoT Hub demo. So why it is showing you that? I have just created it, if I'm not mistaken. Yeah, that was the one that I created. No worries, I'll check that out. So here you can see that if I want to see that, so I can just go to my monitoring utility. I'll go to matrix. And in the matrix, I say that I want to check here that here telemetric data sent or total devices sum. So it shows you one, right? And I can configure it last 30 minutes. Taking data from the cache, I think. Connected devices preview. So 0 devices are connected, right? 0 devices are connected. Now, when I click on this code, right, which I have defined in the Raspberry Pi, right, after defining the connection string, when I click run, it is trying to connect, and if everything goes fine, the lights start blinking, right? And it is sending this telemetric data. Now it is sending this telemetric data. I can go to my IoT hub, and then I can basically see the changes here. Let's see the maximum. So we'll wait. Come on, show me. It's 220. Please be with me just a second. Let me just stop that. It is my IoT hub demo, right? It is correct. Device ID 1 and access keys, everything is fine. So it should show that. Okay, 4 messages, number of devices. And now, okay, it took a little bit time. You can see that, right? It took a little bit time. So it is showing you that now that how many messages it has sent and how many devices are connected. Total IoT devices 1. So when you are running the code here, it is showing you the messages that are sent and how many devices are connected. It will show you that information. Now, even if you don't want to see it here, you can go to the matrix, right? In the matrix section, you can also check the messages that are sent here. There is a option to check the messages. Telemetric messages sent. So 30 messages are sent. You can see that, right? If you want to filter it out last 30 minutes, so apply, and it will show you that the messages that are sent. And this is the application which is sending the messages to it, right? So these are the messages that I have sent. 30 messages are there which I have sent till now, right? So it is just talking about these messages, and now it is updating. Maybe I have sent a little bit more. So when you refresh it a little bit after some time, you will get to know that it has sent more messages. So it is just a little delay in the results. So you can see that 37, as I told you, 37 messages, right? Then it goes, right? So now if you run that application again, let me just click on the application again, and I start that application again. So it will collect and send the data again, right? After some time, when you refresh that, I'm expecting that after that, it will show you the graph which will go at the top. So after some time, it will show you the graph which will going to raise. So I'll keep my application running. So you can see that it is sending the data, right? Let me just stop that now. So you can see that it is doing something. We need to wait. So I'll come back to this like after a little delay, and then you will see that it will going to show you the result. For some time it is down, right? So we can refresh it and it will show you the results after some time. I'll come back to this, right? So this is the way by which you are connecting to it and you are sending the data. Now I have told you two things right here. The one is the security, right? That is in the IoT Hub. If you go with the shared access policy, it contains the permissions that you can use to connect to the IoT Hub and what you can do in an IoT Hub. That's first thing. And if you work with the devices, when you go to the devices, each device has its own connection string that is used to authenticate an individual device. Means per device authentication is there, right? That you can play with. So here you will see that connection string, right? That's we have used to send the data. Okay, so if you want to go with this endpoint, so as I was talking about, so built-in endpoints are there. So IoT Hub says that if I'm using a basic plan, right, basic tier, so send device to cloud is there. Receive cloud to device message endpoint is not there because backend service is not able to send anything to it, right? Yes, it can initiate the file upload, right? Device twin is not there. So it has a very limited endpoints which are available. But if you go with the standard plan, so you will get more endpoints, like devices can send the data to the cloud, backend application can receive the data that it has received, that it wants to receive from the IoT Hub. So it has an endpoint for receiving it. Even the services can basically send the messages back to the devices. So send cloud to device messages. And there is endpoint which says that cloud to device message endpoint, which is receiver. So back the device can connect to this endpoint and receive the message from there. Similarly, the backend service can directly call a method onto the device, right? So there is an endpoint for that called direct method invocation, which is possible, right? So all these endpoints are there. Even you can create your custom endpoints. Like when the message is received by the IoT Hub, it can be forwarded to the storage container, event hub, service bus queues, or service bus topic. You can configure the extra endpoints that you want. We will be looking further into it when the topic will come. Now, security feature, I told you about access control and the permission. Hub level shared access policies are there, or device level permissions are there. So in the device level permissions, we can authenticate a user's request coming from the mobile based on the certificates, based on the symmetric keys, as well as we can use HSM module, hardware security module, right? So certificate, as we talk about, it can be a self-signed certificate, or it can be certificate that is generated by the trusted authority, right? So a security token is generated if you are using a symmetric keys. Based on that, you can authenticate a device and then allow them to send a messages to the device. Now, IoT device lifecycle concept. Now here, this is a device which I have created, right? Now, after some time, I say that, no, I don't want any device with this configuration to communicate with it. So I can select it and I can delete it. When I delete it, it will be deleted permanently. All the settings that I have done with that will be deleted. But maybe I want to temporarily disable it. So in that case, I will not going to click on delete. I will open that. I will click on the disable button here. So I will click on the disable button and it will be disabled, right? So that for some time, nobody can use it to connect to this. So I will save it. So you can see that it is disabled. Now, if I go to the Raspberry Pi and I try to connect, so I'm expecting an error. So can connect error, you can see undefined, because this connection string is not valid. When your request goes there, it says that I do not know about this connection string or this key, right? So you cannot connect that. If you want it, you can enable it again. And once it is enabled, then you can start sending your data. Your devices can start sending the data with that connection string. So sample stop. Now it is about to start now. So let me click run. So you can see that message sent, start sending the messages. So I can stop that. So this is the device lifecycle concept that we need to think about. Okay, so there is some question. Enter the code that you have. Okay. I didn't get that, sorry. You have not received the code. You will receive the code by the end of the day, Ravindra, right? After marking your attendance, you will get Azure Pass and the skill pipe code at the end of the day by your team. Okay, so IoT device lifecycle management, this is like your software development lifecycle. When you click on it, first of all, you have to plan that what device you need to register here, right? What type of authentication you need to have, right? Symmetric key, self-signed certificate, and so on, and you have to save it. Once it is there, then you can use it in your application, and then you have to keep on monitoring it. You have to configure it and you have to monitoring it. And once you are done with that, you can retire it. How you can retire it? You can delete it or you can disable it. So that's what they talk about here. Plan, provision it, configure it, and monitor it, because you are using it, because devices are using that connection string to send the data. And when you're done, you can retire it, either disable it or delete it. So this is the life cycle management process for this. IoT device types. So we have a IoT devices, IoT edge devices. Right. So IoT devices, typically a small scale standalone computing device that may collect the data or control other devices. Right. So in my case, this Raspberry Pi is just an individual device, right, which is collecting the data and sending it to my IoT hub. But IoT edge device is the another device, right, which is installed on my on-premises, which has the ability to collect the data from these devices and then do some processing on it and forward the data to the IoT hub. So that's what the IoT edge devices are all about. It is used when you don't have and when you don't have a, let's say, internet connectivity, when you don't have a connectivity to the cloud, but still you want to get the data from the devices and then send it when the internet comes, first thing. Second, if you don't want to send all the data collected from the sensors to the IoT hub directly, because maybe some of the data is unwanted. So you want to filter the data and you want to do some processing. So in that case also, go with the IoT edge devices. Okay. Azure code will be shared tomorrow. Okay. So that's what we discussed. Now, as we discussed, that simulated devices are there. It is not possible for me to test my code or test my IoT hub with all the physical devices, right? So what I'll do is I'll work with the simulators. And then I can test my application on that. Simulator will give you the same look and feel and same behavior of as if it is a real device. Then comes your next thing is the certified IoT devices catalog. If you want to see that what are the type of devices that can be a IoT hub device, IoT devices, which can talk to the IoT hub. So there is a link provided in the book. You can go there and check that out. Registration, this is what I talked about, IoT device registration. So they are just talking about this section, means provisioning your devices. So go to the IoT hub and go to the IoT devices section and click on new. So when you click new, you have to define the name and then what type of authentication you want to work with. Symmetric key, self-signed certificate, or the trusted authority, right, that you can work with. So that's what they talk about. Both are used to authenticate the device to the IoT hub, and both of these will be discussed later. So this is the device twin. Now device twin plays a very important role. So every device has its own device twin. I'll show you that first of all. So this is my IoT hub. I have a device. If I click on that device, every device has a device twin, which is nothing, is a JSON file. So this is a device twin. So it is a JSON file, right? It has a device identity, right? It has a device identity. It has the properties section where I have a desired properties and reported properties. So I can add some desired properties. I can add some reported properties, as well as I can have another set of properties at another set that is called tags. So tags, right? I can define the tags, and tags is nothing. It is a combination of key value pair. So I add a key, right? That is called, let's say, name, and the value is Sachin. So right, this is a key value pair that I have added. Same with the desired properties and reported properties. Now, what is the use of it? So if you want to see that what is the use of desired properties, reported properties, and so for that, we have to understand the device twin. Device twin. Every registered device has a device twin file, which is a JSON file, it is composed of mainly composed of one device identity properties. Identity properties. It will work with the tags. It has tags. It has desired properties and reported properties. Reported properties. Now, what is the use of these properties and how it works? So to work with this, I'll make a little scenario. So for that, I will say that I have a device property. So I'm having this device twin. So there is a device twin property for a device. And I told you that it has a lot of things. The main things I'll talk about is tags. So it has a tags. It has tags section. It has properties now. It has properties. Properties. And these properties are divided into two categories. One is a desired property and a reported property. So DESIRED, desired property, and another is a reported property. Reported property. Now, let's take an example. I want to create an application for fan management, right? So I have a device. This is a client side. I have a device that is a fan. There is a device one that is IoT enabled fan, and I have an application running on that. So there is an application that is running on that. So there is a application running on that. Similarly, I have the backend application. Backend application. Now, in this application one, which is running on the device, it has a method, let's say switch on, right? Switch off and so on. Multiple methods are there. Hardly matters what methods are there, but it has some methods. Now, how this device twin file will be used? So the tags section will be used by your backend application for read and write. So backend application has a accessibility to the tags, right? And what type of permissions? Read and write permissions. Okay. Now, when and it does not have tags are not accessible to the devices. So desired properties. The backend application has write permissions on that. Write permissions, right? Or read and write permissions. Read and write permissions on that, right? As well as you will get a notifications also. But the device applications have only two permissions on it. One is notifications and read permissions. Two permissions are there. Means whenever something change here, it will give you the notification that this information has been changed, right? So that information will be delivered to you, right? So that is what the backend the device application will use it. Now, reported properties. Reported properties are accessible to the devices in read and write mode. Read and write mode. Whereas the backend application can get this information for two things: read and notifications. So read and notifications. So read and notifications. Okay. So this is what it is working with. Now let's take an example. So when this everything is configured, initially it is configured. So I created a tag that is called current speed, current fan speed, or current speed. Let's say that current speed, and its initial value I set it to 2, right? And my backend application basically use this information to set the desired property. There is a desired property is fan speed equals to 2. So it says that whatever current speed is there, I will write it to the fan speed, and then it gets notified, right? So it uses the desired property called fan speed to set the speed of the fan, to set the speed of the fan, on a regular interval, or maybe on a manual with a manual intervention, I can get the uh, current temperature and send it current temperature and send the temperature and required fan speed as reported properties. Right. It depends on that. Maybe I don't want to send the temperature. I just want to send the fan speed that I need. Right. Let's say that. Make it simple. Right. Get the current temperature and send the required fan speed as reported property. So it writes the data in the reported property, and there is a property called required fan speed. I set it to, let's say that I need a high, I want to run the fan fast, so I make it 3. So when it reads the backend application, I will write a logic. Let's say if the required fan speed is not equal to current fan speed, right? If it is not same, then change fan speed equals to required fan speed. So it does that. So now you know that the value here is 2 and you have sent 3. So they're not same. So in that case, the 3 will be set to the fan speed. And as soon as it is sent 3, then it will update it and then fan speed will become 3. So in this way, you can make a whole environment, right? Does it make sense that how the device twins can be used? Yes. Okay. So this is the main motive of IoT, right? IoT devices. So IoT devices has the ability to collect the data, right, and send it to the backend application, and backend application will do some business process and decide what it has to do on the devices or what it has to do with the data. So that is something that what your device twins are all about. So here they're talking about you have a device app and you have a backend app. So device twin is made up of tags and desired and reported properties. Tags are only used by the backend for read and write and change notifications, whereas desired properties are used by backend for read and write and change notifications, whereas the device app can only use the desired property for reading the data from it and taking an action on it. Whereas reported properties are used by the device app to tell the backend what settings it needs, what information it wants, or what task it needs to perform. And then backend application can read that information and use it to perform an action. So this is what device twin is all about. Device monitoring is another capability. So whatever devices are running, you can monitor that to check the status of it, whether they are healthy or not, right? So you can basically try to connect to the device on a regular interval of time with the dummy messages and see the outcome of it. So it will give you the status, whether it is up and running or it is not. So health, whether it is working or not. So health monitoring utility is there. So here in some of the services, if you go back, right, I'll show you here. If I go back, so you can see that here I have an options to check the resource health, right? If I have configured that, so it will show you the resource health, whether it is available or not. Otherwise, you can diagnose the problem that is associated with it. So it will show you whether the resource is healthy or not, right? So it will give you the complete information about it. Fine. Next thing is all about retirement. I told you that if you don't need any device, if you don't need that entry into it, so that no device can communicate with it, you can permanently delete it or you can disable it. So I have shown you both the options. Now you can see one thing which I told you that this is a device that I have added. So this is the device I have added. In that device, I have configured the device twin. So it is just loading. And in this device, I have added the device twin, and I have made an entry called tags name is Sachin. You can see that. Uh, okay, I forgot to save it, my fault. So tags, I add a key here, name, and its value is Sachin. So I did that and I save it. Now this information is saved, right? Now, if I disable it and enable it after some time, so this value will still persist. But at any point of time, if I delete that and recreate it, I will lose all the information and have to add it again. So that is the drawback of that. So you have to decide what you need. Lesson 4 is all about your IoT Hub developers tool. If you want to work with the IoT Hub, or if you want to work with IoT, so you can work with a portal like what we are doing it here. I created IoT Hub, we register the devices, everything from the portal, or we can work with the CLI, command line interface, or we can work with SDKs. So if I'm working with the portal, it's good. But if we want to work with the CLI, then I have to get an extension, right? I'll tell you what extension I need. Okay. No disable device still be considered when calculating the number of devices. No, they will not. Okay. So I was talking about the developers tool. As we discussed that, you can work with the SDKs. You can work with Visual Studio Code, that is the editors, and you can work with CLIs. So if you want to work with the Visual Studio or Visual Studio Code, you need to download the respected SDKs to work with it. In Visual Studio Code, you need to get an extensions also to connect to the Azure and to work with various resources. Then only you will work with that. So here, IoT Hub SDK, we talked about SDK, Software Development Kit. If you are a programmer, you easily know, that what is an SDK? It is just nothing, it's the library of the classes. So you can use the classes to create a project in the same language in which you are creating the project, let's say C#. So I will get a SDK in C# so that I can write a code in C# only, right? I don't have to work with APIs directly. So it makes my life simpler, as well as the chances of generating the errors are less, and I can even debug that much more easily. And I can easily fix the issues and I can get the proper documentation of it from Microsoft and the communities. The SDKs are device SDK, service SDK, and I told you there is a device provisioning service SDK is also there. Device SDK is used when you're creating an application which runs on the devices. You will go with the service SDK if you want to create an application that are running as a backend application. And device provisioning service SDK is used if you're creating an application that is a backend application, but trying to communicate with DPS. And the SDKs can be downloaded for C, .NET, C#, Node.js, Java, Python, for that respected languages. So these are the languages that it supports, as we discussed that. Sample platforms, as we discussed, IoT devices. So whenever you are working with the IoT devices, so they are lightweight, right? They should not have the full version of operating system. So these are the various operating systems which are supported, right? So you can work with those devices. Windows is not Windows, it is Windows 10 IoT. So it is a lightweight version of Windows 10 that you can work with. Protocols, if we talk about protocols, how the devices can send the data to the IoT hub. So the devices can send the data to the IoT hub based on the protocols, right? Using a protocol. So the 4 protocols which it supports, IoT hub says that the devices can communicate with me using the 4 protocols. One is MQTT over WebSocket, AMQP, and AMQP over WebSocket, and HTTPS. Now, what are these? MQTT protocol basically needs a specific type of port number, that is 8883 port number. So it means that if you have to use it, you have to configure your environment to open that firewall or the rules. Firewall for that port, you have to open that. But if your company does not allow you to do that, in that case, you have to use MQTT over WebSocket because it allows you to work with 443 port number, right? So it works with a 443 port number. Similarly, we have AMQP protocol. If you look into the AMQP protocol, I'll come back to the slides. Just give me a minute. Here they're talking about 5671 is the port number. So you will work with the 576. What was it? Sorry, my fault. 5671. Okay, so it needs port number 5671 and it needs 8883. But if your company does not want you to work with that, so you will work with this where you use 443 port number to work with it, which is mostly open in all the organizations. Right. Now, IoT Hub Service SDKs, as we discussed that, you can get it downloaded in your editor so that you can write a code in C, C#, Java, Node.js, and Python to work with it. So the backend application that I was talking about, this application can be written in the languages that is in C, C#, Java, Node.js, and Python, which can communicate with IoT Hub. So backend scenario, like I want to work with identity registry, cloud to device messaging, direct method, or querying jobs file uploads. So this backend application can communicate with the IoT Hub, right? Why? Because it needs to go with the registration of the devices. It wants to work with the device twins, right? It wants to call some method on the applications, right? So in that case, I have to work with the service SDKs. Means from the cloud to device side, if you want to do any type of communication, you have to go with the server side SDK. Now, where you will write a code, you need an editor for that, either Visual Studio or you can go with the Visual Studio Code. So here you have Visual Studio Code. When you install Visual Studio Code, it is a lightweight editor and you can create any type of project in that. But for that, you need to have an extension. So this is an extension section. You have to add an extension of Azure account. You have to add an extension of IoT tools because when you install IoT tools, it will add the package for IoT Hub, this IoT Edge, and the benchmark workbench. So these are the extra packages that comes with it. You need to write a project in C#, so C# extension is required, right? So depending on what you want to do, you can find that extension and install it. Once it is installed, then it allows you to create a project and integrate with that resource. So this is what the extensions that you need to install. Then CLI tool. Now, command line. If you want to work with a CLI, then you need to add an extension. First extension is for Azure, AZ extension. Then you need to download an extension called Azure IOT. Once you have downloaded Azure IoT, then AZ module will give you an extra commands to work with IoT. Like you can create IoT Hub, you can get an IoT Hub, you can delete it, you can add devices into it. So you can play with the IoT specific services. So how you can see that? You can create, delete, or view the connection strings. You can say that IoT Hub device identity create, device identity delete, work with the device twin, and etc. You can play with that. So this is an example. You are creating, you say that as the IoT Hub create, I want to create IoT Hub in this resource group, and this is a name of the IoT Hub. You can see that you're not specifying any region. You are not even defining the tier. So by default, it will use S1 tier for you. And if you need any help, you can say AZ IoT Hub create. I need a help for that. It will show you the help for that. Now let's see that example. So here I would like to create a resource group first. So for that, first of all, I need to log in into the Azure portal. So I have used AZ login command. When you do that AZ login command, it will going to open a browser for me. And it will say that, okay, tell me which subscription you want to use. I selected it because I have already logged in into the session. So it didn't ask me username and password. You have logged in into Microsoft account. Okay, fine. Now I'll go to that template. So I have signed in. Now I would like to create a resource group. So I will run a command called AZ group create. Right, name, I want to create a new resource group with the name IoT Hub RG in East US region. So it will going to create a new resource group for me, which is called IoT Hub RG. Done. Now I want to create a IoT hub in that. I have already downloaded this extension, right? I have already executed this extension command. So I have already have this module with me. So I can directly run this command. So you can see this. What I'm doing it, I am saying that I want to run a command that is AZ IoT Hub create. I want to create a new IoT Hub with the name myPyHub 2020, some random value in a resource group that I have created at the top with SKU plan that is S1. I entered. So it will take some time. It will validate whether this name is there or not, and it will show you running if this name is not there. And if it is say running, then it will take approximately 2 minutes to create that IoT Hub. Then I'll show you that in that resource group, IoT Hub RG, new hub is there. So let's go to the browser. I'll go to the home and resource groups. So I'm expecting the resource group is there, IoT Hub RG, but when I click on it, it does not have, oh, it has this created. You can see that. Let me see. It is in process. So it is in process and it will going to create it for you. At present, it is in a process of creation. So you can see that may not function properly because it is not active at present. So activating it. So I need to wait. So it will be created using a CLI. And once it is created, then I can do whatever I want. So this is what CLI tools are all about. Cloud Shell. If I don't want to run or install anything on my local machine, so in the browser, it is the AZ900 concept. You go to this link that is a browser-based editor. For the first time when you open it, it will ask you to attach a storage account with that. So I will configure the storage account, use existing. I want to create a new storage account in this resource group, right? And then this is the name of my storage account, file share, my FS, and then I will click create storage. So once the storage account is created, everything is fine, then I will be able to download the extension here, and then I can run the same command in the browser-based editor. So that is what Cloud Shell is all about. So till the moment it is creating, let's see whether my command is executed. No, it's still in process. So that's what Cloud Shell is all about, where you can run a bash command or PowerShell command. Either of the options are there. You can choose the option that you are interested in. Now, this is the last, device configuration and communication. This is device to cloud and cloud to device, how the devices can communicate with it. If you are working with the basic tier, you will only get this option. If you're working with the standard tier, you will get both the options. The protocols, as I told you, MQTT over WebSocket, AMQP over WebSocket, and HTTPS. These are the protocols which IoT Hub supports. But for that, you have to open the port numbers. If you're not opening these port numbers, then WebSocket is the best option to work with it. So MQTT protocols are used on all devices that do not require to connect multiple devices over the same TLS connection. Means they want their own sessions and connections to the IoT Hub. But if you want that all the devices can communicate with the IoT Hub with the same TLS connection, with the same channel, so you can use AMQP. So gateway services used for that, like all the devices can talk to the gateway, forward the data to the gateway, and gateway will use its own connection to send this information to the IoT Hub. So that is the best suited example that I can go with. Right, so you can choose the protocol that you are interested in. We'll talk more on that in the 6th module. Now, considerations, cloud to device pattern. These are some rules that they have given. So you can see that cloud to device pattern. If you are trying to send the messages from cloud to device, means standard edition you're using, and your application wants to send the data from backend to the devices. So you will never go with HTTPS, right? Why? Because it goes with the server polling, and server polling is time consuming. Sorry, right? Right? So we will go with the server push, not the polling. I don't want to waste my time in polling that is there any new data there or not, right? So I don't want to go with that. Then we have the field gateway. So field gateway basically allows you to collect the data from the devices and forward it to the IoT hub. So MQTT and HTTPS do not support sharing a single TLS collection. So in that case, MQTT is, sorry, AMQP is the option that we can go with, right? Then comes the next one, low resource device. I have a device where I have a Raspberry Pi operating system, which is a very lightweight. So it has a RAM, which is, let's say, maybe 2 MB RAM. So I don't want to have heavy packages installed on that. So MQTT and HTTPS are lighter than AMQP library. So on that devices, I can go with these protocols. Network traversal. Like if my company does not allow you to open the specific ports, then obviously I will go with the 443 protocol, either with HTTPS, MQTT over WebSocket, or AMQP over WebSocket. Last but not the least, the payload size, the size of the message. So the MQTT and AMQP are fundamentally binary protocols, right? And thus the payload are more compact than HTTPS payload, because HTTPS will take the data in a JSON format, right? So it is much more heavy as compared to the binary. So we have to think about all these things and decide which protocol I need to work on. Device, I'll take 5 minutes, 10 minutes more maximum. So this is IoT Hub device. Now I told you that this is a device and this is your service. And this service wants to send the data to the devices. So if you are using the protocols like MQPP, AMQP protocol, or you can MQTT protocol, then you have to open the firewalls, but you don't want to open it. So you can go with a new feature that is called IoT Hub device streams, but it is in preview. Don't use it in production. What it does, it allows you to make a secure connection between the devices and service over the TCP protocol. And then you can send the data to each other. That is a benefit. You don't have to open the firewall. It is secure. It is trusted, right? And you can work with it. But how it works with it? So devices, first of all, has to prove its identity with the IoT hub. And then they will make a secure channel with the streaming endpoint. Similarly, the devices, the services can also use its own algorithm to authenticate themselves to the IoT hub and then make a connection to the endpoint. Because now device and services are connected to that streaming endpoint, which is a single, which is basically is using the TCP endpoint, right? So they can securely communicate with each other. The benefit is that data is automatically encrypted and it uses the TLS encryption, right? So that your data is secured. But don't go with this because it is in preview. So I'll show you a code, right? Programmatically, how to use the device side code to send the data to the IoT hub programmatically. You can do a lot of things, but I'll show you a simple code, right? So instead of reading this, I'll show you a practical of it. And then that module is over. So you can see that I have opened the project, right? I have opened the project. Sorry, my fault. So I have opened a project that is created in .NET, right? In Visual Studio Code. Now here you can see that this has a class called simulated device, right? It has a simulated device where I am using the namespace called microsoft.azure.device.client. Means I'm using device SDK from where I'm using this namespace. So I need a object which can connect to the IoT hub device. So I created a variable called device of type device client. Now, which device I need to work on? So I need a connection string. So I'll go to the IoT hub. So I'll go to the IoT hub and I will use this one, right? You can see that this is the one which I've just created it, my Pi hub. It is active. So I'll go to the devices section here and I will register a new device here. So new device, and I call it test device, symmetry key, and I click OK. Okay, device one, and I click save. When this device is created, So this IoT hub says that if you want to send the data to me, right, then you need to have this connection string in your application. So I'll copy that, and then I'll go to the IoT hub again, and I'll go to my code. In that code, I will update that connection string. Now, when my main application when this application start, I am creating an object of device client by saying that device client dot create from connection string. So whatever connection string I've specified, I say that create a device client for me using MQTT protocol. Means this device will send the messages to the IoT hub with MQTT protocol. And once it is connected, then I call my own method called send device to cloud messages. So I have created this method here. In this method, I have created some variables like minimum temperature, minimum humidity, and some random value. I started a loop where I created a variable called current temperature. Current temperature is using minimum temperature plus some random value multiplied by 50, and so on. Same with humidity. Now I created an object of telemetric data endpoint because this is the piece of information that I need to send. And this variable is an object which is composed of temperature and humidity property. Temperature is what you have calculated, humidity is what you have generated here. So this is the data that I need to send. So I will convert that data into a string because it is JSON. I will convert that into the string, and from that string, I get a byte array of it. Now, I would like to send some extra piece of information. So message has a properties collection where I will add key is temperature alert. And I'm saying that if current temperature which is here is greater than 30, store true, otherwise false. So this temperature alert can be true or false based on the value. Then I'll ask my device client to send message asynchronously. Which message? The one it is created. So this message will be sent to the devices. Now I go to the terminal and I will run the command. .NET build first of all. And till the moment it is building, I'll go to my IoT hub. And here you will see that here. So it is showing you 0 devices connected, right? So it is showing you total number of messages from the previous demo. It is a overview of what it gets, right? So total devices are 0. Fine. Let's try to run my application now. So I'm running my application, .NET run. And as soon as I click .NET run, this application will connect and then it will try to send the data. You can see that. Oh, there is some error. Okay, my fault. After changing it, I have not saved this file. Maybe so. This. I click on save. Then .NET build. .NET run. Okay, you can see that. I forgot to save it. That's why it was giving error. Now it is sending the messages. So you can see 1, 2, 3, 4, 5, 6. It is sending the messages. Now I'll go here and I will refresh this. Let's say last 1 hour. And then I will refresh this. So 1 device is connected and it's showing you messages are sending 3. So it will keep on updating it. So 3 is there. So when you refresh it, it will show you more messages after a regular interval of time. Right. So it will show you the messages that are there. Number of devices connected is 3. So when you refresh it, it will going to keep on updating this information here. Right. Otherwise, you can see now 87 messages. Right. So it keeps on updating on regular interval of time and it will show you the results. Otherwise, you can go to the matrix and see the results from there. And when you're done with that, you can stop your application from here, Control C. And when it is
Sachin,
done.
sorry to interrupt you. Can you show the
Yes.
contents of the message if you can? Or
Content, okay. If you want to see that, I have to run a command here. So graphically, it is not possible. What I'll do is I will run one command to show you that. Just be with me. Easy IoT Hub monitor, event hub, and the device name. I have to update that. Just give me a minute. So I'll copy this
sure.
command and I'll show you live monitoring. So I'll click on this PowerShell command, right? And I'll paste that command here and update the details about the IoT Hub and the device. Just be with me. Little time to load that PowerShell. Let me just try. Okay, it's not taking a little time. So what I'll do is I'll go with my PowerShell here, right? I'll show it here. CLS. So I will run that command. That is AZ. I need to update that. So AZ IoT Hub. The IoT Hub. What you want? I have monitor events. Hub name is. I will update the hub name. So hub name is this one. My Pi Hub 22. This. So. Right. And the device ID. Device ID is test device 1. Test device 1. Test device 1. Right. This is what I press enter. So it will going to monitor that. Now let's start my application. So I'll start my application here. And it is sending the telemetric data. So you can temperature is 23 and humidity is 77. Temperature is 25. So here you will be able to see that. Can you see what it is receiving? And then you can see that as soon as you stop this application here, it stops. It stopped monitoring. It says that no data is coming now. The last message is that it receives it when temperature is 24.63 and humidity is 71. So that you can check here, 24.63 and temperature is 71.91. Does it make sense?
Yep, thanks.
So this is how it works. And here ends with the module 2, where we talked about how we can work with the IoT Hub. So there is a lab setup here. This is something that you have to configure your virtual machine, and then how to connect the IoT device to Azure. I have shown you all the example of it. So you will follow the same process to work with it. Now, there are some review questions which are left. We can talk about it and then we are done for the day. I hope you can spend 5 more minutes with me.
Yes, Sachin. Yep.
Okay, great. So nice of you. So we will be covering the first question. So you have to tell me the answers of this, right? What do you think that the answer would be? B2 1 unit. Okay. B. Everybody saying B. Please read the question carefully. S2 1 unit, exactly. Reason behind it, because the capabilities it needs is, you can see that it needs IoT edged, IoT edge, and IoT edge is not available in basic tier. So B1, B2 is ignored, right? So we are left with S1 and S2. So we have to send 5 million messages, right? Like 50 lakh messages. If we go with S1 8 unit, S1 means 1 unit is sending 4 lakh messages. 8 into 4, 32 unit. So 32 lakh messages, which is less. So it doesn't fit into that. S2 1 unit, which sends 60 lakh messages. So this is the appropriate answer. So answer is S2. Right? S2 with 1 unit. Okay. Next is this one, right? That is, you have to choose all the correct answers that apply. Okay. Which of the following statements are true about device twin? What this device twin contains actually? A, device twins are JSON document maintained by IoT Hub. Okay, you somebody say B, N, E, A, B, D. Okay, what about others? A, B, C, D, B, D, A, B, C, D, E. Okay, so first thing is that device twins are JSON document maintained by IoT Hub. No, it is not maintained by IoT Hub. It is maintained by the devices, right? So A is not the answer. Just a second. Take just a second. If you device twin are JSON document maintained by IoT Hub, just a second. It is actually maintained by the devices. So just a second, I can. Yeah, you can say that it is maintained by IoT Hub, because IoT Hub is maintaining that information because it is having the devices, right? Yes. So A is the answer. You're right. So device twins are JSON document maintained by IoT Hub, and how many JSON files it will going to have? It depends on the devices. So each device that is registered with IoT Hub has a device twin. So that is A and B. Now let's see C. Device twin include tags. Yes, include tags, but it does not have anything called cloud properties or the communication property or device property. No. So it does not have this. So C is not the answer. D. It includes tags. Yes. Desired properties, reported properties, and device identity. Yes, it contains that. But there is nothing called reported property. There is nothing called lifecycle property. Lifecycle property is not a part of it, right? So answer is A, B, and D. So this is what the answer is. Okay. Please let me know about this, right? If you're running these two commands, right, then what will be the outcome? So if you run this command in a Cloud Shell or in the PowerShell, right, so then what do you think the answer? Actually, I will tell you this is wrong, right? Because this, according to them, answer is E, but here answer is E only if they change the plan for F1 to S1. Right, S1, because by default here you are creating IoT Hub, right? You are creating an IoT Hub in a resource group. You are just providing the name. You are not providing the tier. So if you're not providing the tier, S1 is the default tier, not F1, right? So by mistake they have run F1 and they have given E is the answer. E is only the answer if the S1 is specified. Okay, the first command will fail. No, the command will not fail. The first command will create a resource group, this in a West US region. Very true. The second command will fail. No, it will not fail. The second command will fail. Nothing, because if you're not specifying the region, or if you're not specifying the pricing tier, it will take a default settings associated with it, right? So answer is basically B and E. So these are the two answers if it is changed to S1. Otherwise, if it is F1, then answer is only B. Okay, so please go through this question. That is the fourth question. And we are left with one more question afterwards. So which of the following are valid options for sending information from the device to the cloud? Device to the cloud. What type of data? Yes. Okay. Device to cloud messages for time series, telemetric, and alerts. Okay. All okay. This is choose all correct answers. Abhav, okay. Abhay said B and D. Abhishek, please look into that again. So BD, B is the answer. C, let's see that whether C is there or not. Device to and reported properties for reporting device state information. Yes, C is also there as you have seen it in the diagram. So reported properties are updated by the application and this information is sent to the backend application. So C is also the answer. D, device to proposed properties. There is nothing called proposed properties. Right, a file upload for media files and large telemetric batches. Yes, file upload endpoint is there that can be initiated by the device. So answer is B, C, and E. Right, if you go with this endpoint section, so here you can see that there is an endpoint that is called initiate file upload. You can see which is used by the device, right? So E is this answer. Now, last one. Please look in the last one, that is which protocols are supported. Very easy. Which are protocols are supported by IIT Hub? All. Yes, all protocols are supported. That's nice. So that's good. And we are done for today's task, though we took like 14 minutes extra, right? Because this is a lengthy course, right? But I'm happy that I have completed the first 2 modules for today. So I'm done from my side. Yes, please.
Thank you so much for your time today, Sachin.
Thanks a lot. I hope they have enjoyed the
Yeah,
session.
I hope everyone would have enjoyed.
Yeah, this was a nice session, actually. Thanks for your time.
Nice. Thanks a lot.
It was good. It was really good. I really, got to know a lot of things.